Hi, we are RIO, and we have prepared this short video to explain to you how our ontology works and how it relates to other objects in our architecture. First, we're going to talk about RIO WordNet, the central ontology of our system. Then, we're going to talk about ontology control, the component which relates the central reasoning unit with our ontology. If you take a look at our source code, you find different old files. As a quick reminder, our system should be able to identify two important things. One, the objects and the classes they belong to, and second, the special relations between these objects. At the beginning, we thought of modeling the objects into categories, static and dynamic. This was inaccurate, as objects we thought were static, which are not moved so often in a room, like tables and big pieces of furniture like sofa, are in reality not static. They can be moved and placed somewhere else in the room, and the robot should be able to perceive these changes. So we decided to make a second version, the RIO WordNet, which is an ontology based on the WordNet online ontology developed by Princeton. Here in the example, you see the class door, which has an inherited hypernym of their parent classes: movable barrier, obstructor, construction, artifact, all the way down to physical entity. In our use case, all the objects the RIO perceives are physical entities, being persons or fruits or objects which have no life. If you take a look at our protege file, you find these relations modeled under physical objects, the parent class for all of the classes found in the RIO system. As an example, we stick with the door and we model a simplified hierarchy relations in the ontology which doesn't collide with other objects commonly found in a room or office. And that's basically RIO WordNet. Oh, I forgot to mention. The relations between the objects are modeled by four very simple object properties defined under the main object property, dynamic property. It has domain and range all the physical objects, as one object can have relations to all other physical objects in the room. And in a 2D case, which is the case that the robot perceives, an object can be either left to, on top of, right of, or under another physical object. So going back to our ontology, we are going to talk now about ontology control. If we go to the source code of ontology control, we notice that it disposes of four services which can be queried by the brain, our central reasoning unit. First, create instance takes the class and the instance number of an object to create an object inside our ontology. As a simple example, we can create, for example, an instance of the class vase, name it vase, and the second input of the method would be the number of the instance, which is in our case 1. We create an instance of vase 1, and it just added, and RIO knows, the system now knows that there's an object in the scene observed, which is a vase. As a simple example, let's create another instance of table. We name it table as a class and also the number 1. And that's basically the service that create instance provides. The second service is create relations, which is responsible for creating the spatial relations between two different objects. In our case, let's say that the vase, which is the object we previously created, has an object relation of the vase is located on top of the table. So RIO would query the ontology to assert this property, that the vase 1 has the spatial relation is on top of, and the instance, which is table 1. And that is basically what this service provides, create relation. In our case, as mentioned in the presentation, we use a k-nearest neighbors algorithm to perform the spatial relations from one object relative to these k nearest objects which are around him, the k closest objects around it. So for example, if the three closest objects to our vase are a table, some keys, and a book, then the special relationships will be created according to these three objects. The third service provided is the query location, and it asks the ontology, it takes as input one object, one instance of a class, for example vase 1, and the method is responsible for querying the ontology for all the relations that this object has with the other objects found in the scene. In the example we just performed here, if we query the location of the vase, it would simply return that it is on top of table 1. But for example, if in the scene were an instance of book 1, and the vase were located also next to and this vase were located also left to our book we just created, it would return these two relations. Remember that the relations are created and returned according to the k nearest neighbors specified by the brain. And at the end we have the method for delete relations, which takes as input also one instance of a class and deletes all the special relations that are present for this class. This is a solution for handling when an object is moved in the space. The brain keeps updating the position and the relations of the object every, currently I think it's 20 seconds, but this is very dependent on the performance of the YOLO. So if we have, the YOLO is our vision system, which you can observe here. So if we have a very powerful system capable of handling mere frames per second, then this relationship will be updated more frequently. Basically that's how the ontology works, how instances of the objects are created, how we have different classes present in our context of RIO, and how the special relations between the objects are queried. We hope this video could serve you as an explanation for your doubts, and we are very happy to answer you any more questions you would have. Thanks for your attention.
Have you ever been at home trying to find that item you've lost and you just cannot find it for the life of you? Well, this is RIO. RIO will help you find it. RIO stands for Robot Item Organizer. And what it does is it looks at a scene. In this case, we've set up a pretty busy room. There's some items here. And it will run with its vision everything through a neural net where it's able to detect the items in the room. It creates instances of the items in our ontology, and then from there we can logically infer where the items are in relation to each other. So basically, if you've lost your cell phone, it should be able to tell you that your cell phone is on top of the table, that it's on the left, but don't let me tell you, let's see it. You want to type bottle. Let's try bottle.
The bottle is left of the chair.
The bottle is left of the chair. This is the chair it's talking about, so that is correct. And do we have any other relations?
Not for the bottle, but we can
Try another one.
the cup.
The cup is left of the bottle.
Ah, nice.
The cup is left of the chair.
Now RIO is using both of its hands actually. Whenever an item is on the right hand side, like the cup in RIO's vision, then it will use the right hand. When something is on the left side, it will use the left hand side.
The laptop is left of the cup.
Laptop is indeed left of the cup. Well done, RIO. Now you want to try an item that it hasn't seen?
The laptop is on top of the dining table. The laptop is right of the chair.
The laptop is right of the chair. Yep, it is indeed.
I do not see the wallet.
Okay, so no wallet, and you could not see the wallet. That's wonderful, RIO. Thank you.